So this will be our first video for Integrated 1, and this should be a really quick unit on kind of some review from 8th grade math that's going to help us for Integrated 1, and just to kind of talk about what Integrated is, which I'm sure I will tell you in class as well. But Integrated is basically two subjects together, so it's algebra and geometry together. So you'll see some topics in algebra and then we'll see them in a geometry lens on top of it, so that we can kind of pull those two subjects together rather than spending a whole year on geometry. We kind of integrate it into Integrated 1, 2, and 3 where they fit in. So today is properties of real numbers, which is going to be again a review, but you should be able to use some of these properties in our first and future units, just to kind of get us ready for this integrated class. So you should have all of these properties, because I think it's kind of silly to have you write them down, but I will kind of write some extra stuff over to the side that I think would be helpful for you to also write down. So the commutative property of addition or multiplication, which means commutative means order of values does not matter. So if you have a plus b, it's equal to b plus a. So 2 plus 3 is the same as 3 plus 2. 5 equals 5, either way. Doesn't matter which order you go in. So this only works for addition or multiplication. So I want you to underline that guy right here, only for addition and multiplication. Would not work for subtraction or division. So if I did 2 minus 3, that's -1. 3 minus 2 is +1. So those are not the same. So addition works and multiplication works. So same thing for commutative property. X times y equals y times x. 5 times 4 is the same as 4 times 5. 5 times 4 is 20. 4 times 5 is 20. If I did division that way, 4 divided by 5 does not equal 5 divided by 4. So 4/5 is like 0.8. 5/4 is like 1.2. So they're not the same. Associative property. So associative property of addition or multiplication means basically you can move your addition anywhere. It's kind of the same thing. Grouping of values does not matter. Kind of the same thing as the commutative property. So see how they have this a plus b, and then so inside a plus b, you got to do those first, plus c. You could do b plus c and plus a. It doesn't matter if it's all addition. Same thing with multiplication. You can multiply in any order is basically what that's saying, just with more things. This is only saying two things. This is saying we have multiple things that we're adding or subtracting. So we've got a times b times c. A and then times b times c would come out the same. 2 times 4 times 7 would come out the same as 2 times 4 times 7. Like 2 times 4 is 8, times 7 is going to be 56. 4 times 7 is 28, times 2 is 56. So either way, you get the same thing. Same with up here with your addition. Identity property is just a number that basically is going to make everything stay the same. So if you add 0 to anything, it's going to be whatever that thing is. So like 1 plus 0 is equal to 1. 3 plus 0 is equal to 3. So you don't really need to add this plus 0 because it's more work to write it. And I'll say this a million times in classes, mathematicians are very lazy and they are not going to write anything that they don't need to. If you need it to like help you out, totally fine, but we would not really want to write a plus 0 because it takes more time than just writing 3. So if you add 0 to anything, it's going to equal whatever that thing is. If you multiply by 1 to anything, it's going to equal that thing. So a times 1 is equal to a. So 3 times 1 is equal to 3. 4 times 1 is equal to 4. Negative 6 times 1 is equal to negative 6. So identities are something that you can add to whatever, and it's not going to change the value of that thing. So a plus 0 is still going to be a. A times 1 is still going to be a. Okay, these ones are probably more important for what we're going to do in algebra, or the algebra part of integrated. The inverse property of addition or multiplication, so using the opposite to cancel a value. So inverse properties of addition is going to be basically you're subtracting. So a plus negative a is going to equal 0. Cancels each other out. So an example of that would be, get my pen here, 3 plus negative 3 equals 0. 5 plus negative 5 equals 0. Negative 6 plus 6 equals 0. So the opposite, they're inverses of each other. They cancel each other out. Same thing with this a times 1 over a is going to cancel each other out, because you really have, if I have a over 1 times 1 over a, it's going to equal a over a, which anything divided by itself is 1. An example of that, if I do 5 times 1 over 5, these 5s are going to cancel out because really you've got 5 over 5, which is 1. Or 3 times 1 over 3, going to be 3 over 3. 3 divided by 3 is 1. So inverses of each other. Addition, the inverse of it is subtraction. Multiplication, the inverse of it is division, which is really like multiplying by a fraction. Property of 0, probably don't use it as much. I mean, we use it a little bit in second semester. Multiplying by 0 is always going to equal 0. So 17 times 0 equals 0. A times 0 equals 0. Negative 1 over a equals 0. Anything times 0 is going to equal 0. Distributive property, this is a big one. Multiply a value of an expression, or a value to an expression inside parentheses. So a times b plus c is going to be a times b plus a times c. So example of that, 2 times x plus 7 is really going to be 2 times x, which is 2x, 2 times 7, which is 14. Negative 5 times y minus z. Negative 5 times y is negative 5y. Negative 5 times negative z is positive 5z, so that's going to change that sign into a positive plus. Okay, last 3 are pretty basic. Again, probably not going to write very much on these, but a reflexive property, a value always equals itself, so a equals a, 16 equals 16, 5x equals 5x, 4y squared equals 4y squared. Really the big thing we're going to see this in is in systems, where we can say if we have y equals 2x plus 3 and y equals 4x minus 7, we know y equals y, so we can set 2x plus 3 equal to 4x minus 7. Symmetric property basically is saying that you can flip the equation around. So if x equals 3, then 3 equals x. You can switch those around if you prefer to have x on the left side, like most people do. We can flip stuff around. If you're given something like this, we can flip 3 equals x to mean x equals 3. Okay. Transitive property means basically if you have two things that are equal to each other, then all of the things are equal to each other. So if a equals b and b equals c, then a equals c. So if 4 plus 7 equals, or 4 plus 3 equals 7, and 7 equals the square root of 49, so both of these guys equal 7, then these two guys, 4 plus 3 equals the square root of 49, which is true. 4 plus 3 is 7, the square root of 49 is also 7. that is it for today. So those are just some properties that we needed to kind of go through so that we are getting ready for this algebra part of integrated. And then we'll pull in some geometry. So most of this is going to be algebra 1, but a lot of it is going to see those geometry properties after we're done with basically first semester is going to be mostly algebra 1. So I hope you enjoyed. Have a great day. Get on to your practice.